Hello everyone! In the last two videos we looked at some details of parabolas. We looked into the symmetry, the vertex, whether they were upward or downward opening. This time we're going to have a look at how we can plot these bad boys. We're going to first have a look at what part we should plot, what kind of requirements our graph should have, and then we will go through an example of actually plotting a parabola and seeing how that works. So first of all, what part plots? Because we can just get started and see if it works out, but then you may end with a graph like this, and I think we can agree that this graph is not particularly useful. It would be nice to at least see the general shape of our parabola. And a way to make sure that we have the general shape is if we at least have the vertex. So with these two requirements we could get a graph like this and have some improvement, but it's not quite there yet. It would be nice if we could actually see both sides of the parabola, if that makes sense. But with these 3 points, general shape, vertex, both sides, we generally have a pretty good parabola. Even better is if we can find some special points in there. But that is not always going to be possible, so those are optional requirements. First of all, you might want to not just have one of the points where it intersects the x-axis, but to have both points of intersection with the x-axis. So for instance, this graph, we have both points of intersection, one at 2 and one at 5. So that one is already a lot better. It is still missing one special point. That is the intersection with the y-axis. So if we somehow manage to add that one, like over here, then we have our perfect plots. Again, the last two parts are not always possible. It really depends on where our graph is. Maybe it doesn't even have intersections with the x-axis. But this is what we strive to get. All right, with that in mind, let's have a look at plotting a parabola. And let's say we want to plot the graph of this function. So we need to get that general shape in there, and we needed to get that vertex. Let's start with getting our vertex. And I'm going to go over finding the vertex rather quickly. If you want to go through it more slowly, go back to my video about finding the vertex. But to find the vertex, we started by finding the point of intersection with the y-axis, and that's just that number 4. And we use that to create an equation of our function equals 4. Then we rearrange to 0, we factorize, so then x is 0 or x plus 5 is 0. So our solutions were x is 0 or x is minus 5. And what we could do with those numbers was, after we solved that equation, the point in the middle, in between, was where our vertex was, because we had that symmetry. Again, this is super quick. If you want to slow down, you can pause this and go through it yourself, or have a look at my earlier video. All right, so that's where x is. Let's also find y, and we find y just by filling it into the function. We fill in minus 2.5 in this function and type it into our calculator. We get minus 2.25. Again, I'm not going to go over the steps there. You can check my first video to see how this works. But that tells us then that our vertex is at minus 2.5, comma, minus 2.25. Okay, so we have this information about the vertex. And we want to have both sides of our parabola. Now to do this, we're going to start with a table. Generally, whenever we plot a function, we want to start with a table. What we do in this specific table is we put the vertex right in the middle, because then on both sides of our vertex we can add some of the numbers. And the next step we do is we have to calculate the results for all those numbers. We can use the symmetry again. Minus 3 and minus 2 are probably going to give the same answer, same for minus 4 and minus 1. But it's just a matter of filling in x to get f of x. And well, we see the symmetry indeed, that's giving us that. So this tells us, well, we're going to make our we're going to create our x-axis from -5 to 0, and our y-axis should cover from -2.25 up to and including 4. So then we have to make our coordinate system with that in mind, and this coordinate system would work. We can fit in that -5 to 0, we can fit in that -2.25 to 4, and we have a bit of extra space. So then what we're going to do is we're going to plot each of those points. So we've got -5, 4, -4, 0, etc. We can add all those points into our coordinate system. And at this point, it may be tempting to think, right, plotting a graph, I need to make nice straight lines, I need to have my ruler. Hopefully you already used your ruler for the coordinate system, but you might think, yeah, I need my ruler here, connect the dots, and I have a lovely parabola. Unfortunately, that would be where you're wrong, because rulers are only when you have to make straight lines. A parabola is not a straight line. So as messy as it's going to get, this one you're going to have to freehand and just try to connect the dots best you can. And if you do that without a ruler and you just try to connect it like that proper, you have your parabola. Going over the steps once more, we started by finding our vertex with all the steps from the previous video. Then we made a table, filling in our vertex in the middle so we could fill in whatever other numbers at the sides. Then we create a coordinate system and we plot all the points, which still gives us our vertex nicely in the middle, so that we have part of the graph on the left, part of the graph on the right. We plot our points and we end connecting them. So that is all there is to plotting parabolas. I hope this helped you in your ability to plot some parabolas, and now let's go ahead and try it out.